Hello and welcome. In this video, we will be looking at the Python package index or PyPI. Most of you might be knowing what is PyPI, but for beginners, let me quickly define what is PyPI. This is a place or a repository where we can find the software developed by other developers in the Python community. You might be wondering what is PyPI? Why do we need to bother what PyPI is, how to use it, and how is it relevant for us? Let's go step by step and explore what is PyPI. PyPI, as I mentioned, is the official repository of Python packages. It stands for Python Package Index, and developers all around the world can create Python libraries or packages and upload to PyPI so that it can be used by other developers in the community. Why do we even need Python libraries? So there are several thousands of libraries available in PyPI, and without this, we will have a tough time because we will have to write everything from scratch on our own, which is tedious, time consuming, and error prone. By having an official repository like this, you, me, or any developer who is interested to write code in Python can come to PyPI, search for the libraries or packages that are already available, widely accepted and tested by the community, and make use of it in our Python code. This makes our development lifecycle very easy, and we don't have to reinvent everything from scratch. So by having a central repository, we have faster development cycles because we will be using the libraries that are already there, and we'll be focusing only on the problem at hand. Now, the other question that comes up is how do we install the libraries or packages that are available in this repository on our system? That is where the utility pip comes into picture. Pip helps us to install a library or a package from the Python package index onto our system so that we can import the functionality from that package and use it in our code. So in this video, we will go through the cycle of creating a package, uploading that to PyPI, and downloading that library from PyPI into our system. Now that you have understood what is PyPI, you will be able to understand that it gives us fast access to thousands of libraries. It encourages collaboration and reuse of code, and it helps in maintaining and distributing the code easily. And this is one of the most attractive feature of Python, that we can have the support of Python libraries that are made available to us by the other Python developers. Now let's see one real world use case where I have a requirement of reading a PDF file using Python code. All I need is to create a Python program, and that Python program will be used to extract contents or text from a PDF file. There are two options in front of me. One is build everything myself. How do I do that? Here I have to write code to parse the PDF structure and understand how to fetch the data from the PDF document, and go ahead and do everything that is needed to open a PDF, read the content, and making use of that code in my actual program. This, you have rightly assumed, this is time consuming, error prone, and very complex. And will have to spend a lot of time to ensure that our functionality is working as expected. The other option that I have is to leverage the power of PyPI. This way, we'll be using some package that is widely tested and approved by the community. There are several such packages that are available, say PDF Plumber, PyPDF2, etc. You can just identify which package to use, go ahead and do a pip install of that package, and write code based on that. So it will be fast and easy to implement, and it will be well documented and maintained, and it's all you need is to do a simple pip install and the library name. This makes our life very easy. Now let's see how we can publish something into PyPI as a package so that other developers can make use of it. Before we do that, let's take a look at the PyPI portal itself. Let me open my browser, and the website can be accessed by typing pypI.org, and this is the PyPI welcome page or home page. As you can see, there are several of the projects listed, and there is a option to search for libraries, or there's an option to browse for projects. Let me click on that. So what you see is that we have a set of filters on the left side. We can pick a mix and match of any of the filters and search for the package that we're interested in, or we can make use of the search box to find the package that we are interested in. Let me just type PDF and hit enter. So here you can see all the packages that are available for our PDF parsing. There are several of them. You can see that there are around 500 pages of libraries, around 10,000 plus projects for PDF. The one that I was referring to, yeah. So this is the library that I was referring to in the previous slide. There's a PDF plumber, and once you click on it, you will know that how to install that using pip. There is a pip install command, and we'll also see a brief description of what this library is all about, a way to install it, and some basic examples, how to use it in a Python code, etc. etc. This page is very useful so that it gives a high level idea on what is this library all about. Also in the details section, you can see who is the maintainer of this code, what is the license under which this library is distributed, what is the Python version that is required to successfully use this library in our code, and what all programming language version this is applicable on, is it OS dependent or not, and so on and so forth. There are tons of information available in the page for any library. Once you come to that package description page, you will have a lot of information available which you can refer and make sure you're using it the right way. Another thing to talk about is you can also create a login to this portal. The login comes with a API token, so that will come handy when you're about to publish a library into PyPI. Another thing that is worth mentioning is that there are two portals. One is PyPI, this is the main portal, and there is another one called TestPyPI. It is test.pyp.org. This is a separate instance. So you can see that it has the same look and feel as that of the main repo, pyp.org, but this is like a staging area where we can upload our packages before pushing it into the main repository, so that we can verify if our package details are proper. For example, let's say I pushed this library into the test PyPI. Once the upload is successful, I can come to this page to see if the appropriate project descriptions and other details, the maintenance detail, email detail, the home pages and other URLs are available. We can also verify the license that we specified and the Python version, etc. So this helps us to ensure that the package that we have created and uploaded is fine and contains all the information that we intend to share with our end users. So this is all about test PyPI. What we have next? Yeah. So here we are talking about how to publish our own packages into PyPI. So we have to follow a set of steps to make this happen, and we have to use certain tools that are available via pip install. The tools to build our project, the tools to publish our project, etc. that we will cover one by one. Let's see what we need. We have to have a standard structure for our project. Then we have to create a pyproject.toml file that should contain the metadata, and it should also contain what build mechanisms to use to build our package. It should also have a README, a license, and a file which is dunder init. There are two underscores before the init and two underscores after. So in Python terms, we call it dunder double underscore. It's dunder init.py. And once we have everything available, and once we have the Python code that should be part of our package, we can come back and build the package using a Python build command. Once the build is successful, we can upload the package to PyPI. Before we upload to the actual repo, as I mentioned, we should upload to the test PyPI for ensuring that all the information is available. Once it is available in test PyPI, we can go to that URL, search for our package, install that in our environment using pip command. Once it is available in our environment, we can import and use it with our Python projects. So we will go step by step and see each part of it. So the first step, we have to have a standard project structure. So this is the project structure that is recommended. All these details that I'm talking about is available in PyPI main page. There is a link here. You can see learn how to package your Python code for PyPI. Click on it. You will come to a detailed page that talks about each of these steps, how to do it in Linux or macOS, or how to do it in Windows. The first thing that it talks about is a folder structure. Then it comes to another section where it says what all files are important in that folder and how to build it using certain specifications in the pyproject.toml and so on and so forth till we actually publish. So the entire details are in this page in PyPI. I'm just summarizing that for our ease of understanding. So all we need is a root folder structure, and that should contain certain files, certain folders. Let's do this as we speak. Let me go to my Windows Explorer, and I've selected one particular folder. So let's start from there. Let's see what all we need. So this is the structure. Let me create my root folder here. Root folder, let me name it as, say, dummy package, dummy package demo. Inside that, I need two subfolders, src, which will contain all my Python source code, and let me create one more folder, which is the tests folder. So this is the convention: source and tests. Source contain all our package source code, and test should contain all our uh, package tests code, all the Python scripts that is used to test our package. Now let me go inside the src, and here we need a folder which should have the same name as your package. So let me create that. What name shall we give? Dummy pyp demo package demo. This is the package name that I'm giving. Just to ensure uniqueness, I'm just appending it with my name, br123. This is some string that I chose to ensure that it is all unique. So this is my package name. It will appear like this in our TestPyPI or PyPI. I have this file, I have src and a folder. Now it's time to create our Python files. Let me go to my text editor, and in my text editor, let me open a new file, save as src, yeah, and I have this package name, yeah. So my file should be named dunder init. So dunder init.py. This can be an empty file. I'll leave it empty for now. So let me just save that file, dunder init.py. Save it. Now I need a Python file that should contain my code. So let me create a simple file. Let me create a file. Let's put some Python code in it. Def add 10 return plus 10. So if you don't understand what this is doing, you can ignore that for now. So what I've done is I've just created a file, added a Python function, add underscore 10 to it. This function takes in a number as an input, and it returns uh, a value which is equal to the number plus 10. Just some code for my package. You can add anything meaningful here. So let me just go and save this. My name, say my code.py. So we have two files under source, the dunder init, and there is a Python file with whatever name, and it has a function which returns the value which is equal to the input number plus 10. Now these two are done. Let's move on to tests folder. Now what we need is a tests script, Python script. So for now, I'm not adding any script. For this demo, I'm just going with an empty file. So let me go back to tests folder and create my tests.py. All right, here we are. So we are done with the first two steps of putting some content in the src and tests folder. Now let me go to my text editor again and create a readme.md. Let's put something like this is a demo package. Do not use this. So whatever meaningful stuff that you want to talk about your um, library, you can put it in a markdown format. For now, I'm just putting some dummy text and save this as readme.md, choosing the file extension of .md. All right, now let's see what all we have. I have a root folder, I have a source, test, and readme. Now we need these two files. The license file, which talks about what license under which I'm distributing this, and there is a pyproject.toml. I will come to the license later. Let me focus on the pyproject.toml. So for that, let me just create these two files, empty files, and then we'll discuss each one in detail. I need an empty file that should be named as pyproject.toml. I need one more file which should be called the license. So let me open a empty file, just name it as license. I don't want any extensions on that. So license, save this. Now let me go to that folder structure again. So now we have everything: source, test, readme, license, and pyproject.toml. Now let's start filling up the contents of pyproject.toml and license. All right, so here we have a bare bones version of project metadata that should go into the pyproject.html. We have information on build system, project, and obviously the license file. So what is this build system? Now that we have the Python source, we need some mechanism to build or bundle the source code into a package format. And there are several utilities available to make this happen. And build has a build backend and a build frontend. So build backend is nothing but the actual utility or actual exes or actual programs that do the build, and build frontend is something that will just trigger the build by invoking the right build backend. So here in this demo, I'm using one of the build backend, which is called hatchling, and there are many other build utilities available. We'll see that in the PyPI in some time. So once I specify the build backend, what is to be used for building my package. The other details are about the name of the package, the version of the package, who is the author, what is the email address of the author, what is the description that I want to give for the package, where is the README located. Currently, as you can see in the folder structure, the README and the pyproject.toml resides in the same folder. So we can just give the name instead of a path here. And the next thing is the Python version that is required. So I'm publishing a package. Along with that, I have to tell my users on what versions of Python this package will be applicable. Say, for example, I might have developed this package on Python, say 3.13.5 version. What if the user is in a version which is 3.9? Will it be supported or not? So we are giving that information by specifying this requires Python greater than or equal to the version that we have tested it on. Now the other part is some classifiers. Classifiers is nothing but some information that help the user to navigate the Python libraries in PyPI and come to a position where they can search for this package. Here it's just say that it is for Python version 3 and it is an OS independent package. Then comes two important pieces of information: the license type and the license file. So you have noticed that I've created an empty license file, just like I have an empty pyproject.toml here. Let's copy this information, everything available, into our pyproject.toml. We will start filling the actual values in some time. Here it is. So let's try to fill in whatever information that we currently have. We know the package name. Let me go back to my folder structure. What is my package name? My package name is, this is my package name. So it is under my src folder, dummy pyp demo br1. Let me put that here. Make sure you replace the placeholder content with your package name. What should be the version of this package? Let's say I'm doing it first time, so let me put it 1.0.0. The author name and the email. So here let me put the author name and let me put the email name. We are at example.com. You can replace with the right values here. Now, description for the package. We can give a description, say dummy package for web. All right. I know that I have created a readme.md in the same folder. So let's keep it as it is. Requires Python. So in my case, I have not tested the package in other versions of Python. And in my environment, the Python version is 3.13. So I'm just putting it requires Python 3.13. Any Python version above 3.13 should be able to install and use this package is what I'm conveying. Classifiers, I'm not changing anything. It is on Python 3 and it is an OS independent package. Now let's come to the main part here, the license related information and the build information here. Now, as I mentioned, the build backend and build frontend is something that we have to just keep in mind. The backend is the actual tool that performs the build. Examples are hatchling, plate, poetry, setup tools, etc. These are the actual build tool which converts our Python source code into a format that can be uploaded into PyPI and from where it can be downloaded and installed by tools like pip. The front end is nothing but a tool that talks to the backend to trigger the build. So we have tools like build command, which is most common, and we have pip command to install. So the front end needs a way to tell that, okay, you go and build the source code, but use this build backend. And that is what we specify in the requires and build backend. Now, how do we get this information? Let's go back to PyPI. If you come to PyPI, there is a section here. Yes, there is a section where it is talking about the build front end, back end, etc. etc. It talks about different build backends, and one thing that I'm using is the hatchling. Let me go inside that. So that opens up the page talking about the build backend hatchling. Go to the docs, and in that we will have a lot of information about that build backend. And going through that documentation will tell us what is the right values to be used in the build system in pyproject.toml. So in my case, since I'm using hatchling, I have to use a requires hatchling, and build hyphen backend parameter should have a value hatchling.build. This is what we need for hatchling. For other backends, you can go to the respective documentation and you will find what is appropriate values to be placed. Now let me go back to the main page. Yes, here further down, if you go to the other sections, yes, you have detailed documentation on what each parameter is all about and what values to be filled. In our case, you might remember I'm using this as a dummy, and to know what license or license file, there is a indication of what is this license term all about. It is a SPDX license expression for the package or software package data exchange format. So go inside that. This is the place where you have to go. It will tell us that these are the several examples that are available. But to be sure, let's go inside the link to understand what those terms are. So here we are in the detail page. If you scroll down further, you can take your time to go through this, but if you scroll down further, you will see a section where it talks about valid SPDX expressions. I am planning to use the MIT, so let me pick it, come to my pyproject.toml and use it there, MIT. Now, this talks about my license file. Where is my license file located? You might remember that I've created a license file here, which is empty, but let me finish this part by giving the name of the license file, license start. So this means that anything starting with license and any extension can is the license file that is available. So let me save that. As you can see, all these parameters are available and filled. Now the main question comes, what is the content to be placed in the license file? Again, PyPI comes to our rescue. Go to PyPI. If you go further into the PyPI documentation, it talks about something like creating a license. How do we create a license? There is a URL given here. So let me click that and see what happens. It talks about various types of licenses that are applicable. Since I'm planning to use MIT, this is the link that I have to click. it takes me to the MIT license. Uh, Obviously, you can go through this license text in detail and see what permissions and conditions and limitations are applicable for this license. Let me copy everything and come to my license page, save it. Just going back, we have the pyproject.toml field, the license field, the readme, and all the other contents are filled. Okay, now it's the time to build the package, upload it to the TestPyPI, and test the package by doing a pip install. For that, let's go to the first step, which is building the package. For that, let me navigate to my package folder. This is my package folder, and let me open the command prompt. I am in the dummy package demo folder. First step is to build python -m build. As I mentioned earlier, build is a build front end, and we will be using hatchling as the build backend as per the specification given in pyproject.toml. Let me invoke build. You can see that it is using hatchling. So it did something, and we see that it has two files created under distribution folder, dist folder. One is the source code itself, and other one is the package format that will be uploaded into the repo. Now that we have built the package, what do we do next? Before we proceed, I want to tell you that to make sure this command succeed, you must have build installed into your system. It is using pip install. We will cover that in a later video, but in my setup, build is already available. That is why this command succeeded. Let's go to the next step, which is upload. Let me copy the command as it is from here. And what we have is we are relying on another tool called twine and uploading the package to a repository. The repository URL is testpypi.org/legacy, and everything under the distribution folder I'm uploading. That is what this command is telling. Let me go there, clean this out and say paste. Twine command is uploading something to a repository which is testpypi.org/legacy, and it is uploading everything under the distribution folder. Let me try this. And here is the API token that I referred earlier. Once we create an account in TestPyPI and PyPI, we will get the API tokens. We have to store them safely somewhere so that whenever there is a need to upload a package to PyPI or TestPyPI, we have to provide that. So it is saying that the package is uploaded and it is available at so and so URL. Let me go to that place. Control and click on that link. It will take you to the test PyPI page for my package dummy PyPI demo BR123. Version is 1.0.0. You can see that the project description, the maintainer details, the license detail, and the classifier, everything is coming in here. Also, there is a description that is coming at the top, dummy package for demo, whichever text I gave during the package development. And this also gives me how to install this package from TestPyPI using the pip command. Pip install, and it is taking a URL as a source from which I have to pick the library. The library name is dummy PyPI demo BR123, and the version to pick is 1.0.0. So if you click on this, the entire command is copied to the command prompt. You can open any command prompt and paste it. So it is just doing a pip install from a given repo, which is TestPyPI, and it is taking the package name and the version as input. Let me click on enter. You can see that the pip has successfully contacted the repo which is mentioned here and downloaded the version of the library that is specified. All right. So now with this, we have created a package. We have uploaded that to TestPyPI and we have successfully installed that into our system using pip command. We are not getting into detail of how to import that in a Python code and use it. That we will say for another video. You have a pretty good idea of what is PyPI, why is it relevant, why do we need this, and you have also learned that by using PyPI, our development cycles will be faster. You also have learned about how to publish our own libraries into PyPI or test PyPI repo. All right, with that, we have come to the end of this video. Thank you for watching. Please like, share, and subscribe to this video and support the channel. Also, let me know your feedback and comments on the comment section so that I can improve the content and come up with some more useful videos like this. Thank you very much.